Okay, on number 9, we want to solve this for y, so I'm going to take the square root of both sides, and you have y equals plus or minus the square root of 2x minus 3. So when you do the t-chart, on the positive side, you would just put in 3 over 2 because that's what makes this equal 0, and that's going to be where the vertex is. So I pick that point. And then if I put 2 in there, you're going to get both positive and minus 1. If you put 6 in, you're going to get both positive and minus 3. Okay, because you're going to get the positive first, but because that negative is on the outside with it, it's both positive and negative. So when we graph these, you're going to go over 1.5, which would put the dot somewhere in there. Then you're going to go over 2, up 1, and down 1. Over 6, 4, 5, 6, up 3, and down 3. And so when you open it, this is a parabola that opens to the right. Your domain is it starts at 3 over 2, which is 1.5. It includes it, but it goes to infinity. You can't include infinity. Range is you start at negative infinity and go to positive infinity. All right, on number 10, that's a circle, and the center of the circle is at 0, 0, because there's 0 values with the x squared, 0 values with the y squared, so that's how you end up with that. The square root of 25 is 5, and that's your radius. So the center is right here. You're going to go up 5, and down 5, to the right 5, and to the left 5. And there's your circle. The domain goes from negative 5 to positive 5. Ugh, that's awful. Negative 5 to positive 5, it includes it, so it gets a bracket. Your range goes from negative 5 to positive 5. It includes it, so it gets a bracket. On number 11, before you can solve for an x that's under the radical, you have to isolate the radical, which means we're going to get rid of this 4 from both sides. And so you have square root of 5x minus 3, and it equals 3. The absolute value, it's not the absolute value, the square root is by itself, so we're going to square both sides to get rid of the radical. And so you have 5x minus 3 equals 9. You're going to add 3 to both sides. 5x equals 12. I'm going to come over, rewrite it over here. 5x is 12. Divide both sides by 5. And so x is 12 over 5, or if you choose to, you could write 2.4. Okay, hold on. Okay, so this is your answer, but it says to check for extraneous solutions. And so I'm going to plug that back under the radical, and that is 5 times 12 over 5 minus 3 plus 4. This is going to cancel, and you end up with 12 minus 3, that is a 3, plus 4. The square root of 12 minus 3, okay, that's 9. Square root of 9 is 3 plus 4, which is 7, which is exactly what it has to equal, so this is a true solution. On number 12, you're going to add 5 to both sides, and you end up with 2 equals 1/3 to the 4th root of 2x. I'm going to multiply both sides by 3. 3 times 2 is 6. 1/3 of 3 is 1, and you're left with the 4th root of 2x. To get rid of that radical, it's the 4th root, so you're going to put it to the 4th power. So 6, oh man, I don't even know what that is. 6 to the 6th power, 6 to the 4th power is, hold on, is 1,296, and that equals 2x. Divide both sides by 2, and x equals 648. Okay, plug that back in, and let's see if this works. That's going to be 1/3 the 4th root of 2 times 648 minus 5. 2 times 648 is 1,296. The 4th root of that, let's see, is 6. 1/3 of 6 is 2. So you have 2 minus 5 is -3, and that's exactly what we had to get for this to be a true solution, and that works.